Greetings and welcome, friends. Mr. Waddy here, going to show you how to translate verbal phrases. We're going to be communicating both in English and the language of matemáticas, which I just said in Spanish. I'm sorry. But yes, English to math. Math is a universal language, and we're going to sometimes be communicating about it using symbols and written language, and other times we're going to be communicating about it verbally, or in this case, with words. And we're going to want to make sure that we all understand, we all know what we mean when we use these words, that we have the same dictionary, so to speak. So here we go. I'm jumping right in. Here's an example. It says, write a numerical expression for each verbal phrase. So expressions, numerical expressions, were made up of numbers and operations, right? Those are kind of the things that are at play. So for part A here, it says the product of 8 and 7. Now, I'm going to actually be super slow about communicating this. I'm going to be taking my time. And so this is what we got. The product of 8 and 7. So when I read the word product, I'm assuming this means multiplication. All right, so multiplication. When I see of, right, so here's now it's going to give me the two things that I am multiplying. And so let's actually even highlight those. Product of 8 and 7. I'll even throw that in a different color here. The product of 8 and 7, that is the numerical expression that I get when I hear the phrase, right, the product of 8 and 7. Now, product, which operation did we categorize that as? As multiplication. Does anyone know another way that we could communicate that same operation? Because just because I have this as my mathematical expression doesn't mean that we all would have used the same words to describe it. So does anyone know another word that they could have used to describe this? Another phrase? Thoughts? Shy? Someone might have written 8 times 7, right? Yeah, 8.7. I would actually count that as a numerical expression rather than a verbal phrase. But yeah, that's actually really good. Mathematically, now that we're in Algebra 1, we're going to shy away more and more from using the kind of little X-style cross for our multiplication symbol because, as we'll see today and tomorrow, we're actually going to start using variables more frequently, and X and Y are going to be letters that we use all the time, and we want to avoid confusion as much as possible, so we're going to avoid using that X sometimes. We also theoretically could have used parentheses to imply multiplication there as well. 8 times 7, so times is another way that I could describe that operation. What's another word? 8 multiplied by, right? So we'll just kind of keep trying to think of some words that can describe this operation as we go on. I'm sure we'll even encounter more. Let's look at this next example. The difference. The difference. Which operation do you think is at play here? Subtraction. So notice the moment I hear this word, I'm reading the sentence in order. This is what I'm imagining. I'm thinking of difference. I'm subtracting two things, okay? You wouldn't draw those boxes necessarily, but so the difference of, and now the next two things I'm expecting to hear, the first thing I hear, I would expect to go in the first slot, okay? And the second thing I hear, I would expect to go in the second slot. And for subtraction, do you think that the order matters? I'll ask that again in a moment. Let's see. So the difference of 9 and 3. So difference of 9 and 3. So this is what I would get. This is the numerical expression for this verbal phrase. And is 9 minus 3 the same as 3 minus 9? No, they would be, they'd have the same influence, right? They'd have the same absolute values, but one of those would be negative, the other would be positive. So the order matters for subtraction. So whenever I have difference or division as well, the order is significant. So I actually have to make sure I'm translating this correctly, because if I write the problem down wrong, I'm not going to get the same answer as everybody else by any means. So 9 minus 3. What's another way to describe subtraction in a word? What's a word? If so, difference is one of them. Uh, Sometimes you might hear the phrase less than. Sometimes you might hear the phrase, the word minus, right? 9 minus 3, or let's see, or 9 subtract, right? So there's a couple words that all mean the same thing mathematically. So we're just gonna have to write those. I think in the English world would be called synonyms, where they mean the same thing. I also might be completely wrong about that. Maybe I'm just sabotaging your English understanding. Who knows? But my objective is to teach math right now, and maybe that is what I want to do. I want you to know less about English and more about math. Ooh, be interesting. So let's see, subtract. For the less than phrase, the order I write that in would actually matter as well. I would actually have to say the following. I'd say 3 less than 9. Okay, so when I say 3 less than, that means I'm taking it away from something. And so the first thing I would have written was the minus 3, and then the number that or the thing that comes after this would have been the thing I was subtracting from. Okay, so there's some other words that describe the same operation as subtraction here. So let's see. Let's do some more examples here. Oh man, my little scroll bar guy, he hides on me a little bit too well. He goes invisible. He's like a hobbit wearing a ring or something. Rough. So let's see. Here's some more phrases. We'll do these together. And so I don't want you to just be thinking about like, oh, what's the answer to this problem? How do I write this mathematically? I also want you to be thinking about what words communicate which operation. All right, so it might not even be a bad idea. You could even just draw a box of like addition, subtraction, multiplying, dividing, and then in each box just keep throwing more words that mean the appropriate operation. Okay, so let's see. All right, here we go. All right, here I am. I'm up there. Let's figure this out. So 6 minus 3. So minus, which operation is at play? Addition, subtraction, multiplication, division. Subtraction, I agree. And now let's figure out. So 6, actually I should have written 6 first. 6 minus 3, this is what I'd end up having. 6 minus 3 looks like that. And that would evaluate to being just regular old 3, obviously, right? But the order matters. So minus is another word that I can use for subtraction. Let's look at this next one. 9, so I hear the word. Whether I'm visualizing this or I'm writing it down, someone says 9, I'm like 9. I write 9 down. Multiplied by, so let's see, that's sounds like multiplication. That's a pretty good guess. So 9, we'll use the dot this time, how about we? Multiplied by 5, and so the next thing that I hear, I would have expected to be the thing that 9 was being multiplied by. Okay? All right, let's keep going. 24, so 24 double digits right here, divided by, so you could use this symbol here. We're actually going to end up shying away from the use of that symbol over time as well. Divided by 6. So that's one way you could write it. An alternative way to write it would have been, you could have written, that 2 came out funny, 24 divided by 6. We'll start using fraction bars a little bit more. You theoretically could also do like the little sideways fraction bar. Not as big of a fan as that. Most of the time we'll be leaning towards writing things kind of like as a vertical upright sort of fraction. But you can also use this symbol for now. But you'll see as we progress through Algebra 1, we'll mostly be writing things this way. Let's see, let's keep going. Ooh, oh boy. The cost of 3 notebooks at $6 each. Oh my goodness. This is complicated. All right. Cost of 3 notebooks at $6 each. Does anyone have any guess what operations at play? What am I even doing with these numbers? If I have 3 notebooks that are $6 per, 3 times 6, I agree. So 3 and 6, this is tricky. I don't know. I know, let's see. Of sometimes can mean multiply. I'm trying to think of what words clued me into that, or if I just happen, I'm so used to just thinking about this in terms of, right, that each kind of, or at $3 or $6 each. I think the of is kind of one of the things that clued me into it. But yeah, 3 times 6, right, $6 for one notebook, and then you just multiply that. That'll give you your total cost. I might even go as far, and we're not here yet, but I might even go as far as saying cost equals 3 times 6. So the total cost represented by C, but we'll do more with variables in a minute. Let's see. All right, 7. All right, that's easy. Increased by which operation? Addition, I like it. By 2, and we've seen 2 by 4, 2 before. Which actually another multiplication term that I haven't mentioned yet is if I have the word twice or double. Right, those are words that both mean which multiply by what? Yeah, multiply by 2. Okay, so there are other words that are like very specific to the type of multiplication that we're doing here. So I do want to just point that out. Yeah, I just reminded me of that right there. Okay, wow, I really like these last two here. So 11, so I'm writing the number 11, more than. Which operation do you think that is? More than. Now, some people might even assume this, which maybe you've seen back in the day, a greater than symbol, but that would only be the case if I have the word is there. We'll talk about is showing up in a little bit. But 11 more than, that means I'm adding 11 to something. So something is being increased by 11. All right, and then 15 is that thing that I was increasing it by. Now, notice I wrote that a little bit backwards. Now, the most like literal translation of this, when I say 11 more than, means I'm adding 11 to something. Okay, so I actually write the plus 11 after the thing that I'm adding it to. Now, in the case of addition, you could have gotten away with it. You could have done 11 more than 15, which is not the way the phrase is written, but these are mathematically equivalent expressions. Okay, 11 plus 15 and 15 plus 11 are both equal to each other. That's actually called the commutative property of addition, where you can add in any order, right, and it won't matter. That is not the case for division or subtraction. So this next problem I like a lot, because here it matters. 4, so I'm going to write the 4, less than, which operation? Minus, right? I'm subtracting. Now, am I going to do 4 minus this way, or is 4 being taken away from something? Yeah, I'm taking it away from something. 4 less than, so I'm thinking like, oh, I was somewhere, and now I'm 4 less than that place, right? So yeah, I'm taking it away from something. So 18 minus 4 is the proper wording for this. And I want to point out that if you did 4 minus 18, this is an incorrect translation, and it's also mathematically not equivalent. So the stakes were higher, so to speak. There was a lot more at risk with that problem. So you could have gotten away with it for the adding one. This one would have worked out for you. but I want you to still train yourself nonetheless to try to literally translate these as best as possible. All right, questions so far? No, we're good. We're good. All right. You're good. You're good. You're good. All right, here we go. All right, where's my scroll guy? Here we go. Why does he hide on me? You don't need to hide. I'm your friend. Okay, here we go. Translating verbal phrases. The first step in translating verbal phrases into algebraic. Ooh, what's the difference between algebraic and numerical expressions? We haven't heard yet. Is to choose a variable and a quantity for the variable to represent. This is called defining a variable. So algebraic expressions differ from numerical expressions. Let's see, right? We mentioned numerical expressions earlier. Numerical expressions have numbers and operations, whereas algebraic expressions also include variables, which often will use x or y or t for time or length or width, right? We'll have all sorts of crazy things: circumference, area, volume. We'll have all sorts of things that represent variables. They can be lowercase, they can be uppercase, all sorts of things like that. So let's see if we can do some of these types of examples. Let's see, translate each into an algebraic expression. Whoa, little jumbo there. Here, I don't know if you could stop the clicking there if you don't mind, just so we can focus. So, translating each phrase into an algebraic expression. So let's see, 12 points more than the Dolphins scored. So let's see, so what is my variable? What should my variable be? I don't know how much the Dolphins scored. So we can come up with a letter for that. Let's let D equal points scored by Dolphins. All right. I wonder, are there any sports where they actually let animals compete? I mean, well, I guess like dog show, like where I'm trying to think of where it's just the animal, not like horseback racing or no greyhound racing. Pokemon battles, obviously, it's primarily the animal competing. I understand Pokemon is not real. Let's see. So my variable that I defined here is the Dolphins, what the Dolphins scored. And so here we've got a phrase that says 12 points more. So let's I'll use this. So 12 points more than, the operation is addition. So I'm adding 12 to something. And how do I represent the Dolphins' score? With the letter D. So D plus 12 is how I'd represent that. And you didn't have to use the letter D. You could have used X. You could have used P for points. Also, just in terms of this, I'd like to point out that Dolphins, the D is measured in points, and 12 is also measured in points. That those are actually the same units in this case. We'll do some unit analysis, dimensional analysis later on in this course. Okay, let's take a look at this. 4 times a number decreased by 6. So what should my unknown thing be? What should my variable be in this case? I don't know what number they're talking about. So my variable, yeah, question, comment? Well, actually, I think this will have, yeah, 2 operations at play. I think there's multiplication and subtraction. Yeah, so but either way, I've got to commit to a mathematical symbol to represent this number first. So like I need to pick a variable, right? A letter. So I'm going to use X, and I'll just say X represents the number or whatever. I don't know. In this case, it's not a very interesting variable, but that's fine. And so 4 times a number. All right, so I've got 4. Operation number 1 is times, so that's product times a number. In this case, it's x. You could have used n for number. Decreased. So what operation is that? Yeah, subtract, and then lastly by 6. So 4x minus 6. This actually multiplication, Austin, when you have a variable and a number being multiplied, you actually don't need to have an operation written next to them or in between them. If I just write 4x, it is implied that that is being multiplied. Okay, so you don't even need the dot there. This is a cool way to write it. So just like back in the day when I had write 4 parentheses 2, and I assumed that meant multiplication, or even 4 times parentheses 2 plus 1, and we interpreted that as multiplication. The same thing here. If you have 2 variables side by, or a variable next to a number that it's being multiplied by, you don't have to write it. Now, question: if I wanted to write 2 times 3, why can't I just say that's the same as 2, 3? Why is that a bad idea? Why can't I get rid of the multiplication symbol? Yeah, it looks exactly like 23. We already use that notation when we're talking about a ones digit and a tens digit. So I absolutely need that multiplication symbol if it was just 2 numbers. But in that case, it doesn't matter, right? For a variable. Let's try a couple of these. Let's see. I'm going to select a few of these here, and then we'll and then I want to teach you a couple more of these special phrases that actually imply more than just an operation. Okay, so here's 2. The quotient of a number and 4 minus 5. So let's see. So I've got to define a variable. So my variable, let's say n equals a number, or the number, whatever. So quotient, what operation do you guys think quotient means? The one that starts with Q. Oh man, that's not one of them. Quotient. All right. Quotient means division. I'm going to use a fraction bar at this point. And division, the order matters. So the quotient of a number and 4, these are my 2 inputs. The first input will be my numerator, the top, all right, or the thing that is being, right, divided into, and 4, okay, and 4, right there. And minus 5, which operation is minus? Subtraction, and then lastly 5. Okay, so there's my algebraic expression, right? It's algebraic because it has algebra in it. Algebra is when we start introducing variables, letters that represent numbers, okay? And now that I actually have this expression, I could then even ask you questions. I could say, like, what is this equal to when n is 16, right? Or when n is 100, and then you could actually plug in values for n using parentheses, and you'd be able to evaluate those expressions. Okay, let's look at this this last little example here for this so far. The 7 increased by the quotient of a number and 8. So I'm going to define my variable first. I'm going to say W just because of Waddy. What's up? You could make up any variable name you want. So W is equal to a number. And let's start seeing if we can figure this out. So 7, so when I write this, I'd have 7 increased by what operation? Addition, multiplication, subtraction, division, exponents. Increased, when something increases, we are adding to it. So that's addition, right? So there's another word where, like, if I didn't know what the word meant, I would completely misinterpret this problem. So increased by the quotient. Wow, so it's increased by, now this is another operation. So it's increased by something that's going to be a fraction. Quotient is division. A number, so the number is in the top here. Here, mine's W. You could have used your first initial or whatever. And 8, so ocho. Okay, not bad. Not bad. Let's see. I want to give you guys 2 new phrases. One of them we've already heard, and it hasn't mattered. But let's see. Here we go. But these can be and will be significant when we're dealing with translating. So here's 2 new words: sum and difference. We've already heard the word difference. Difference we knew meant subtraction. But sum and difference communicate more than just a regular operation. All right, when I hear the word sum, S-U-M there, I interpret that as addition within parentheses. So I'm adding 2 things with priority over other operations. It's meaning add first, okay? Add first. And when I hear the word difference, it refers to subtraction with priority. So it means subtracting within a set of parentheses. So I'm subtracting, 2 things. It looks like a cool face that I made, some sort of like little emoji thing, right? So I'm subtracting or adding 2 things in parentheses when I hear these words. And then the next 2 things you'd hear after these words would be, right, the first thing would go there, the second thing goes there. The first thing would go there, the second thing goes there. All right, so these, the order matters, and in this case, right, it is significant that this operation takes place with priority. Let's see, so let's do this little example. So translate the phrase into an algebraic expression. So 3 times the sum of a number and 7. Okay, so I've got a variable here. I'll say m for math. We'll say m is equal to a number. And I'm going to color coordinate this. I realize you might not have all the colors. That's fine. So let's see, 3. So I'm going to write 3. That I heard the word 3. I write the number 3 times. Which operation is that going to be? Does it mean you just check the clock and write down whatever time it is? What operation? Multiplication. And now I hear the phrase the sum, which is an operation, okay? And it means addition with priority. So I'm going to write plus, but with parentheses. And now the next 2 things I hear will go in these parentheses in order, okay? So the sum of a number, in this case I called my number m, and 7. Okay. So 3 parentheses m plus 7. In this case, because of the parentheses, you could have excluded the operation of the dot there. We could have ignored that and we would have been fine. Question. What if I wanted this to be what I meant? 3m plus 7. So I'm changing it up. What's a way I could have worded this? What words could I have used to describe this that wouldn't have accidentally meant I meant that? How could I have worded this? Can we do it the other way? If I give you an algebraic expression, do you think you could give me words? So let's see, I'd start with 3. I've got an operation of multiplication. So I could have said the product of 3 and a number. I could have said 3 times a number. I could now just say plus 7. Right, that's one way I could say it. I could have said 7 more than. Man, I just wrote 7 more than. 3, or the product of 3, I guess I'll write it out, I've already committed, and a number. Right, there's quite a few ways I could describe this. If I wanted it to include parentheses, though, the sum is a good way to do it. Another way I could have worded this one is 3 times the quantity. That's a funny one. Don't mix that up with quotient. Quantity of a number plus 7. Okay, so if you hear the phrase quantity, the quantity, that means like this next group is a set. All right, this happens first. So that's a way to describe parentheses without necessarily having committed to which operation you're doing just yet. Okay, let's see. So difference behaves much in the same way, and remember, for difference, the order absolutely matters. Okay, for difference. Wow, I love how colorful this is turning out. Last thing for this video. Here's an interesting question. Now, we haven't talked about exponents yet. Exponentiation, or raising something to a power, right? You symbolize that by writing it in a superscript, is the way that you would describe that. You write the font size is smaller, and you write it above the variable. Exponents, there's an exponent button on a calculator that looks like this. It's called a caret, C-A-R-A-T, I believe. And sometimes you'll also have a y to the x button on some calculators as a way to get the exponent property or operation applied. But here's an interesting question. How could you verbalize this expression? So this, if I said 3 to the x plus 1 to describe this, what I'm actually describing is this one over here. 3 to the x plus 1. Okay, I'm not actually going to write this down. I'm just going to say it. So 3 to the x plus 1 describes this quantity over here. How could I describe this where I want the plus 1 to be in the exponent? Oh, fire drill. Well, thanks for visiting, math friends. We'll talk to you later.